You're watching the Target 6.3 retest video. In this video, we're going to learn how to solve equations with rational exponents or square roots, radicals. So make sure you have the white packets. Make sure you're taking notes. And then any questions you have, you can rewind it and watch it again. Listen to the words. Don't have your headphones on. Listen to the words. Um, and if that doesn't work, go see your teacher before or after school. Here we go. We're going to do number 1 and number 3. Now these first few problems I'm going to take a little slow. These are probably the easiest ones that you'll see though. So remember that the square root, when you have square root means the 1/2 power. So the 3 steps that we're going to use on these is we're going to isolate either the parentheses or the square root. And then we're going to do the inverse. Usually this means the reciprocal of the power. A lot of big words there. You'll see it when we get there. And then you're going to have something to solve, and it's either going to be linear, or it's going to be linear like you did in 8th grade, or it's going to be quadratic like you learned in Unit 5. So knowing that the square root is that 1/2 power, when we get to the second step, the inverse, the 1/2 power, you undo the 1/2 power by doing the 1/2 root or the second power. So since this is the second root, we want the second power to undo it. So we're lucky in number 1 and number 3 because it's already isolated. So the first step is already done for us. So to get rid of the square root signs, then we undo that by doing the squared power, second power. And undoing that then just gets rid of the square root symbol, the radical, on both sides, and we're left with that. Now this one, if we just do the solve step, is just like a linear equation you would see in Algebra 1. So we're going to add 2x to both sides, and we get 1 minus x equals 4, and then we'll subtract 1 from both sides, and you end up with negative x equals 3, and then we'll divide by negative 1, and you end up with x equals negative 3. So this last little bit is stuff that you learned a while back. Isolate, or get the x by itself on one side, get the number on the other, and then you'll have to divide to get your answer. So number 3 is very similar. Number 3, the square root's are already isolated, so step 1 is already done for us. And we undo the square root by squaring. So squaring square roots gives us what's left on the inside. There you have it. And now it's just like a linear equation again. So the x's or v's or letter, the variable does not need to go on the left-hand side. I will add 2v to both sides. So it looks like this one ends up with the v on the right side, the variable on the right side. And then we'll add 8 to both sides. And you end up with 4v's equal 32. And then we'll divide by 4. We'll end up with 8. Okay, in all of these problems, we want to make sure that we get a positive number that you're square rooting. So taking the square root of a negative number will give us an imaginary answer. In this case, that won't work. So if we plug negative 3 in where x is here, you end up with positive 9 or 10. If you plug negative 3 in here, you end up with positive 6. And we add 4, you get 10. So when we plug 8 in here, you get 16. 24 minus 16 is good. And 8 in here, 16 minus 8 is good. So both those answers are just fine. The next set of problems, we're still going to follow the same 3 steps. Isolate. Do the inverse of what you see there. And we'll solve what's left. So in number 7, it's already isolated for you. So we just need to square both sides. You end up with 4 minus 12k equals 64. So notice that gets squared. Now it's again just a linear equation. So we'll subtract 4 from both sides. And then we'll divide by negative 12. And end up with k equals negative 5. Okay, plugging in negative 5 into for the k, you end up with a positive answer. Okay, but in number 8, we're not isolated. So this negative 6 is bad news. So we need to add 6 to both sides, and that gives us an isolated radical. Now we can square both sides. You end up with 102 minus b equals 10 squared, or 100. Subtract 102. Negative v equals negative 2. Divide by negative 1. You end up with v equals 2. Again, when we plug 2 into the equation, we're not taking the square root of a negative, so we're good. Let's move on to 13 and 14. These end up being a little bit more difficult. Again, isolate is already done, so we're squaring both sides. You end up with 16 minus 6k equals k squared. And now k squared. This is not a linear equation, this is a parabola. So we are going to have to solve it like we did in Unit 5, which usually means factoring. So let's move everything onto one side. Plus 6k, because we add 6k to both sides. We're also going to subtract 16, so it ends up being minus 16. And now we're thinking two numbers that multiply to be negative 16 and add to be positive 6. It's k plus 8 and k minus 2, which gives us k equals negative 8 and k equals 2 for the answers. Now, remember before we checked all those answers to make sure that they work. So when you plug negative 8 in here, you end up with the square root of 16 minus 6 times negative 8 equals negative 8. This ends up being square root of 64 equals negative 8. Well, that doesn't work. Square root of 64 is positive 8. So this one will not work. But 2 in there, 16 minus 6 times 2 equals 2, and up with the square root of 4 equals positive 2. The fact that this is positive makes sure that it works. So that negative 8 is called extraneous because it doesn't work when you plug it back in. All right, we'll do another problem like that and you'll see it work again. Hopefully, we'll see. So this one's isolated, so let's square both sides. End up with negative 50 plus 15x equals x squared. Again, it's a parabola, so we'll have to move everything over. 0 equals x squared minus 15x plus 50. Two numbers that multiply to be 50 and add to be negative 15 are x minus 10 and x minus 5. This turns into x equals 10 and x equals 5. So, checking them again, we have the square root of whatever is equal to 10. With this one, that's okay. So this one works. This side, you have the square root of whatever you get inside is equal to positive 5. That works also. So those extraneous answers happen when you get a negative solution and the square root is equal to a negative number. That doesn't work. So when you check your answers in the back, if it only has 1 but you have 2, chances are that other one is extraneous. All right, let's look at the last set of problems. These are rational exponents. So again, we're still going to follow the same 3 rules. We're going to isolate. We're going to do the inverse. In this case, you're really going to see this one work, and then you're going to solve. So 19 is already isolated for us. The inverse now, this is the third root and the 5th power. So we need to do this to the 3rd power and the 5th root. Notice it was reciprocal. So the 3rd power and 5th root takes care of that exponent, which leaves us with 33 minus n on this side. And then according to your power sheet again, the 5th root of 32 is 2, and 2 to the 3rd power is 8. Now it's a linear equation. We can subtract 33, end up with negative n equals negative 25, which means n is 25, and we're good. And since we're taking the cubed roots, positive or negative answers, doesn't matter. They all work. Now in this one is an isolated, so let's subtract 2 from both sides first. Now we can talk about the inverse of 3 halves. Remember, this is the third power, second root. So we're going to do everything to the second power in third root. So how does that work then? Third root of 8 is 2. 2 squared is 4. Then this side, the third power and the third root, second power and second root, they cancel out. Left with k minus 30. Adding 30 to both sides, we get 34 for an answer. Again, positive negatives work. We're all good. So there you have it. Don't forget, it's always isolate, do the inverse, and then solve what's left. Sometimes you'll have to factor, sometimes you won't. If you need any more help, rewind this video, check it out again. Go see your teacher before or after school, get it done so that you can retest and raise your grade.